Students, this video is a review of the entire factoring unit that we went over in class. We're going to be talking about GCF, DOTS, which is dots, the perfect square trinomial, also known as, this is a special case of the AM method, and grouping. What I want to do is take a look at the problems that you're going to look at in class. I'm going to do the odds and the evens we're actually going to be doing in class. So you'll get an answer to all of these odd questions. So let's start off with the first one. It asks us to factor the common factor out of each expression, which means we're looking for the number or variable that is common for each factor. So take a look at that first one, try this out, and then see if you got it right. The suggestion is to pause the video to try to answer this question and all the subsequent questions. My first step here was to look between the numbers and try to figure out the GCF of the numbers. For example, 16 and 4, what's the number that goes into both of those? Well, between 16 and 4, the number that goes into both of them is 4. That's the largest value that goes into both of them evenly. In other words, the greatest common factor of numbers. Then between p to the fourth and p to the third, it's important that we look for the smallest exponent, because if you think about p to the fourth, that's 4 p's. If you think about p to the third, that's 3 p's. Well, there are 3 p's here and at least 3 p's here. So the greatest common factor between these variables turns out to be the smallest exponent, which is going to be to the third, p to the third. Now we do the leftover step, which is I divide both of the terms that are already there by the greatest common factor, and then we can determine what's in the leftovers. My leftover step, I did 16p to the fourth divided by 4p to the third. I know 16 divided by 4 is 4, and p to the fourth divided by p to the third, I would subtract the exponents. Think about it like this. I'm looking at p to the fourth, which is 4 p's multiplied by each other, and p to the third, which is 3 p's multiplied by each other. Remember, when you're multiplying two terms on the top and bottom of a fraction, they can be eliminated like this. We can eliminate this pair, we can eliminate this pair. This pair just turns into 1, right? P divided by p is equal to 1. P divided by p is equal to 1. P divided by p is equal to 1. And we got 1 p left over at the top, which means p to the fourth divided by p to the third is equal to p to the first. A quick way to do that without writing it all out like this is to subtract the two exponents. 4 minus 3 is 1. So that's p to the first. We just write it as p. 4p to the third divided by 4p to the third, well, they're exactly the same term, so I'm left over with just 1. Be careful. A common student mistake is to say, oh, 4p to the third divided by 4p to the third. They eliminate. I don't have to write anything. Keep in mind, my leftover step has to have the same amount of terms, right? My leftover step needs to have 2 terms as the original expression. If there's 2 terms in the original expression, my leftovers need 2 terms as well. And the greatest common factor is its own thing. It comes to the front of a set of parentheses. All right, take a look at number 3. Pause the video, try it out, and then see if you got it right. Again, I look at the numbers 63 and 45. The greatest common factor between these two is 9. That's the largest number that'll go into both of them evenly. So 9 comes out in the front. Notice that there's a b term here, but there's no b on this term. There's no variable on the first term. It's a constant term. So since there is a b on this one, but there isn't a b on this one, they don't have any b's, any variables in common, so I can't take out any variable. So that b is just going to stick around in my leftover step. 63 divided by 9 is 7, 45 divided by 9 is 5, and the b stays there, and there's no b here because there was no b to begin with. All right, take a look at number 5. Number 5 asks for you to do the same exact thing. Take a look at the GCF, pause the video, try this out, and then come back to see if you got it right. When I'm looking at 2 negative terms, we often like to factor the negative part out of the terms as well. I know that both of them have 6, so I'm going to factor out a 6. And again, the smallest of the 2 exponents between 5 and 4 is going to be 4. So my r to the fourth is part of the GCF. Now I'm going to do my leftover step. Keep in mind the negative 6 came out, 4 of the r's came out, so the only thing left over here would be r. And since 6r to the fourth and negative 6r to the fourth and negative 6r to the fourth are the same exact term, I'm left over with just 1. A negative divided by a negative does give me a positive, so that's going to be plus 1. And you can check yourself by saying, well, what if I multiplied negative 6r to the fourth times 1? Well, of course, I get negative 6r to the fourth. Yeah, it's a good way to check to make sure you did it right. Last GCF here, I'll go ahead and pause the video, try it out, and then see if you got it right. And 14, 21, and 21. This is 3 terms, but that's okay. We just look for the number that's in all of these 3 terms. 14, 21, and 21. The greatest common factor of numbers is 7, And then all of them have at least one a. The smallest exponent value is 1, so my GCF has a exponent value of 1. There's my leftover step. I divided 14a divided by 7a, 21a squared divided by 7a, etc. All right, moving on to dots factoring. You know that with dots factoring, we're going to take each of the terms and square root them. Once we square root them, that'll be the value that goes into each of the parentheses. Here's the first example. Go ahead and try to pause this video, try it out, and then I will show you the correct answer. Difference of two squares, I'm looking for two numbers that are perfect squares, or two terms, I should say, that are perfect squares. 16 is a perfect square because 4 times 4 is 16. N squared is a perfect square because n times n is n squared. And 9 is a perfect square because 3 times 3 is 9. So I square rooted both the first term and the second term. I got 4n and 3. That means I'm going to construct my factors using 4n and 3. 16n squared was first, so 4n is going to go first in the parentheses. 9 is second, so 3 is going to go second in the parentheses. It looks like this. One thing that you should see is this. This 4n is going to be populated in both of the first spots of my factors. This 3 is going to be populated in both of the second spots of my factors. And then the difference between these two operators, this minus and this plus, has to be there. You can rewrite these two terms, making 4n plus 3 in the front, looking like this. Notice that you could put the plus first and then the minus second. These are exactly equivalent expressions. They're both going to multiply together to 16n squared minus 9. So it's not necessary for you to write it in minus plus form. You can put it in plus minus form. It really does not matter. It looks like number 3 is not dots factoring. I'll remove this from the document that I give to you. Let's skip down to number 5 and try to factor that using dots. Pause the video, try it out, and then see if you got it right. For this one, I'm doing 9x squared square rooted. The square root of 9 is 3. The square root of x squared is x. And then 1 square rooted. Of course, 1 is the first perfect square because 1 times 1 is 1. So 1 goes in both of those end spots. A minus plus because difference of two squares means the two signs, the two operators are going to be different. And then we are done with this problem. Not too bad. If you know the pattern, dots becomes pretty quick. Number 7 has n to the 4th minus 100. Keep in mind that n to the 4th still can be square rooted. Try this one out, pause the video, and then come back to see if you got it right. In order for you to solve this problem, you needed to know that the square root of n to the 4th is equal to n to the 2nd power, or n squared. Why is that? Because n squared times n squared, that's n times n times n times n. That's 4 n's in a row. That would be n to the 4th. So here's the dots factoring of this problem. But here's that dots factoring. I know that n squared is the square root of n to the 4th, so I put the n squared in both of these places. 10 is the square root of 100, so I put that both in these places. Now, if this 10 were a perfect square, I could keep factoring, keep going, right? I would factor completely, in other words, and factor more than once. However, the 10 is not a perfect square. There's no number that multiplies by itself to give us 10, so we just leave it like this. This is our correct and complete answer. Let's move on to the next page of this document. Let's look at AM factoring. You should try that first one and then come back to see if you got it right. All right, my method, AM factoring, is looking at a trinomial with a something squared at the beginning with no leading coefficient. I'm going to try to figure out the numbers that multiply together to give me that C term and add together to give me that B term. So let's take a look at all of the factors of 7. I'm looking at 1 times 7 and also negative 1 times negative 7, which also gives me a positive 7. The reason I do that is because it may be that this middle term is going to be a negative. Looking at these answers, though, it looks like 1 and 7 are going to be my two factors that multiply together to 7, but also add to positive 8. 1 plus 7 is 8. So I'm going to set up my two parentheses just like I did with dots, but 1, or positive 1, or plus 1 is going to be in one of the bubbles, and 7, or plus 7, or positive 7 is going to be in the second bubble. Actually, it doesn't really matter whether this one's the first bubble, this one's the second bubble. Same thing with dots factoring. We're using the commutative property of multiplication, so it doesn't matter which one goes first. It does not matter whether you write b plus 1, b plus 7, or b plus 7, b plus 1. It's going to be exactly equivalent to each other, so no difference there. Let's take a look at the third one here, m squared plus m minus 90. Keep in mind that the coefficient of m here is 1. So when you're doing your add multiply method, you need to be looking for a number that adds together to give you positive 1. That's a little hint for you there. So pause the video, try it out, and then come back to see if you got it right. here are all of the pairs of numbers that multiply together to give us negative 90. There are a lot of them, but remember we're looking for the pair of numbers that add together to 1. So I'm not going to look at the numbers like negative 5 and 18 because they're kind of far away from each other. I'm looking for numbers that are really close to each other, like negative 10 and 9, for example, or negative 9 and 10. Looks like this one's the one we're going to do it because these two numbers add together to give us positive 1. So the factoring looks like this. Of course, remember, based on the commutative property, we could write this as m plus 10, m minus 9. It would make no difference. Moving on to the last one in this row, it's n squared minus 10n plus 9. Pause the video, try this one out. This one's going to be a little bit quicker, and then see if you got it right. Looking at 9 here, we can see that 9 and 1 are the factors, negative 9 and negative 1, 3 and 3, and negative 3 and negative 3. Got to always remember to write down those negative factors, especially in this case because the negative factors here are going to give us the correct answer. We need two numbers to add together to negative 10. That means negative 9 and negative 1. No big deal. So the factoring looks like this. Amazing. We're going to skip AC factoring. We're going to go directly to factoring completely. Take a look at that first one, see what you can factor. Remember, we're always going to try to do GCF first. Pause the video, try it out, and see if you got it right. You can see we factored out a 6 out of all of these terms. 6 goes into 6m squared that many times, m squared times. In other words, 6m squared divided by 6 is just m squared. 12m divided by 6 is 2m, and 144, which is negative, divided by 6 is negative 24. That's the GCF method. Next, I'm going to write down the other method that I use here, and it looks like I can use AM method here, so I'm going to write that down as well. All right, here are my factors of negative 24. It's nice that we got to do the GCF factoring first because I didn't want to find the factors of negative 144. This is a much smaller number. Now I'm looking at these numbers, and the trick is I need to find numbers that are 2 apart because they need to add up to 2, and it's not going to be 1 plus 1. There's no 1 plus 1 here. I need to find numbers that are pretty close to each other, that they're 2 away from each other. Maybe one of them is 2 larger than the other one. So I'm not going to use negative 1 and 24 because one of them is much bigger than the other one. But it looks like negative 4 and 6 has the property that one is 2 larger than the other one, right? Negative 4 and 6. The 6 is 2 larger than the 4. So that's what this is going to look like when we use the AM method. That answer is correct and complete. I'm going to move on to the next one. N to the third minus 5n squared plus 6n. Looks like all these terms have a common factor. Pause the video and see if you got it right. All right, n is my GCF. It's the GCF of variables, and this term doesn't have any numbers, so that must be the only GCF. Now I'm going to take a look and see if I can factor the next one, and of course I can using that AM method. All right, here's the correct answer. I know that n minus 3 and n minus 2 are the two factors of n squared minus 5n plus 6. Let's try to hold off for a second on giving the exact reason why. Maybe you can see, why does negative 3 and negative 2 work in this case? Okay, I'll tell you. Negative 3 times negative 2 is positive 6, and negative 3 plus negative 2 is negative 5. Just go down the factors of 6 until you find the correct answer. Last but not least, I have 2b to the third minus 12b plus 16b. Pause the video, try this one out. Looking for GCF first, and see if you got it right. All right, the GCF is 2b, or is it not to be? No, I think it's 2b. 2b to the third, 12b squared, and 16b, they all have at least one b, and they all have 2 as a common factor in terms of the numbers. Okay, 2b comes out, b squared minus 6b plus 8 is inside. Of course, we're going to try to use that AM method again. So here's what it looks like. Okay, our correct and complete answer is 2b times b minus 4 times b minus 2. And you know that minus 4 and minus 2, they come from the factors of positive 8, and they add up to negative 6. The last thing that we want you to look at is factoring word problems. I'm going to pick one of these to go over with you together, and then you're going to try the rest of them in class. Take a look at factoring word problems. The first one, if the area of a rectangle is this, a squared plus 11a plus 18, find the dimensions of the rectangle. Keep in mind that the dimensions of a rectangle just mean the length and the width. So we need to find the length and width, and we know that the area is supposed to be a squared plus 11a plus 18, and you know that the area of a rectangle is equal to length times width. which means I'm going to take this area and plug it in for A. And I need to find two things, L and W, that multiply together to give us A. Turns out to be just a factoring problem, right? I'm looking for length and width, two things that multiply together to give us A squared plus 11A plus 18. So I'm going to employ my AM method again. Here's how it looks. All right, again, I looked at the factors of 18. I know that 9 times 2 is 18, and also 9 plus 2 is 11. So there I go. There's my two factors. I also know now that the length and width are going to be, well, I guess the length is the longer one, so A plus 9, and width is the shorter one, so that's just going to be A plus 2. The next part of the question says to find the perimeter of the rectangle. Let's draw the rectangle first to see what it looks like. I think this is a pretty fair picture of a rectangle. It's got A plus 2 as its width, it's got A plus 9 as its length, and you know for a rectangle, whatever side this is, whatever measure of side this is, it's the same on this side, and whatever side this is, it's the same on this side, right? If this was 5 inches, this would be 5 inches. So let's label the rest of the sides. Okay, there's my labels, and you know that the perimeter is when you add all the sides of a shape. When I'm adding all 4 sides of this rectangle, that means I'm taking A plus 9, A plus 2, A plus 9, and A plus 2, and adding them all together. Here's how that looks. So it looks like that. And now, since we're just adding in between these parentheses, we're just going to add all sides regardless of the parentheses. Combining like terms, all of these A's become 4A, and 9 and 9 is 18, 20, 22. So the answer should be 4A plus 22. All right, hopefully that made sense. And that's all the time we have for this video. Remember, this was a Common Core Algebra video about all of factoring techniques. We reviewed all the factoring techniques that you're going to be tested on coming up, which means I get to say, good luck studying.